Let's solve this question. ABC is an acute angle triangle. Point BEFG are taken on side AC. So let's just draw an acute triangle ABCD. A, B, C. This is the triangle. And it is given that point B, E, F, G are taken on this side AC such that AD is equal to BE, that is equal to EF, which is equal to FG, and which is equal to CG. Or it is given that these 4 points are equidistant from each other. So let us assume or break this line into 5 equal parts. That is the D, E, F, G. So this is D, E, F, and G. Also, points PQR are taken on side BC. So 3 points PQR are taken on this side such that BP is equal to PQ, which is equal to QR, and which is equal to RC. So also these 3 points are equidistant from each other. So just to break this line BC into 4 equal parts, which would be, this is 1, 2, and 3 points P, Q, and R. Now, find the ratio of area of quadrilateral DPQF. I need to find the ratio of area of quadrilateral DP, Q, and F to the area of triangle GQC, that is GQC. I need to find the ratio of these two, that is area of quadrilateral DPQF and area of triangle GQ. I need to find the ratio of this. Okay. I know these points are equidistant from each other. So these distances are equal. These distances are equal. Also, these distances are equal on this side. Okay. Let's just take this triangle. For triangle FQC, for this triangle FQC, I know this G is the midpoint. This length QG will be median. And I know a property that median divides the triangle into 2 halves of equal areas. So let's just assume the area of this triangle be X. I'm assuming the area of triangle GQC as X. Area of triangle FQG will be X. Now, let's just take this triangle DPC, and just join this line DQ. Just join this line. I know this area, or let's just assume this triangle DQ and C. In this triangle DQC, this F is the midpoint because FC is equal to FD. If I assume this distance as 1 unit, 1 unit, 1 unit, and 1 unit, these distances are equal in this triangle DQC. So I can say this median QF will divide these two triangles in equal areas. So I can say the area of this triangle will be 2x because area of this triangle FQC is 2x. So it will be 2x. Now, let's just take this bigger triangle DPC. This point, this Q is dividing the base in the ratios. This is 1 and this is 2. So because these two triangles, I am talking about this bigger triangle, that is DPC, and I am talking about this triangle DQC. These are on same base. The ratio of area of triangle DQC upon area of triangle, this DPC would be how much? Let's just draw the height. If this is the height, this is the height for DQC, and this is the same height for DPC triangle because these two triangles are on the same base. So let's just find the ratio of their areas. So area of DQC would be half base half base that is QC, that is 2 units, into height is h, upon PPC is half base that is PT, which is 3, into height. So ratio comes out to be 2 by 3. Ratio comes out to be 2 by 3. So I can say the area of this triangle DQC is 2 times the area of this triangle. This whole triangle is 3. So area of remaining this triangle, this smaller triangle, that is DPQ. Area of triangle DPQ will be area DPC minus area DQC, that is 3 minus 2, or 1 unit. It is 1 unit DPQ. This is 1 unit, and now let's just observe this 2 unit area of triangle DQC is 4x. These 2 units correspond to 4x area. So 1 unit will be x. This 1 unit will be 2x units of area. So area of triangle DTQ is 2x. This is 2x. So I can easily find the ratio of these two. Area of quadrilateral is 4x. Area of this triangle GQC is x. So ratio is 4:1. Simply using the properties that triangles are on same base, so their areas, the ratio of their areas will be divided in the ratio of their bases. I'm using these simple properties to get the answer. So correct answer to this question is option B.